Okay, so let's have a look at example 8 on page 10. It also uses proof by contradiction. We want to use the technique that we've just introduced of supposing not. So suppose the original statement is false, and then we want to somehow prove a contradiction happens, which means our assumption is false, which means our original statement is true. So example 18 says, show or prove that 1 over x plus 1 over y does not equal to 1 over x plus y for x and y values in the reals which are not equal to 0. Okay, so write down what you want to prove. We want to prove that 1 on x plus 1 on y does not equal to 1 over x plus y for non-zero values of x and y. So we're going to proof by contradiction. So proof by contradiction. Proof by contradiction says, suppose not. Suppose our statement is false. So we're supposing that the opposite of this statement, or the opposite of not equals to, is equals to. So we're supposing 1 on x plus 1 on y equals 1 over x plus y, for non-zero values. So contradiction says, this is our statement, our original statement, prove, which we want to prove. So suppose that our original statement is false. So the opposite happens. So suppose that this equals the right-hand side for non-zero values. We need to show that if we make this assumption, then it leads to a contradiction, which means this assumption is false, which means our original statement must be true. So, okay, let's work with what we assumed, that 1 over x plus 1 over y equals 1 over x plus y. If we want to add fractions, we need to have the same denominator. So I'm just going to times y times x times x. So I get y plus x over x times y. And the denominator equals 1 over x plus y. Because I have two fractions equaling each other, I'm going to cross multiply. So I have x plus y all squared equals xy. So based on the suppose not, right, I get the relationship that x plus y all squared equals xy. Okay. Now, consider the left-hand side x plus y all squared. So any number squared is always bigger than or equal to 0, right? Because a squared number can't be negative. Now, I'm also making the claim that this number cannot be equal to 0. So I'm saying that x plus y all squared is bigger than 0, and x plus y all squared does not equal to 0 since x and y are not equal to 0. So if things are not equal, if two numbers not equal to 0, no matter how you add or square them, you can't get 0 as the answer. Now, because x plus y all squared is equal to xy, and we established that x plus y all squared is positive and not equal to 0, therefore xy is also positive because these two are the same. So therefore xy is also positive. Now I'm going to ask you to consider something else. Now consider x plus y all squared is xy. So this relationship we established, based on the assumption that the statement we want to prove is not true. If you look on the left-hand side, we can expand that. So that becomes x squared plus 2xy plus y squared equals xy. I'm going to rearrange this so that I get x squared plus y squared is xy minus 2xy. So x squared plus y squared is negative xy, because 1 minus 2 is negative 1. Now, think about the left-hand side. X squared plus y squared. Again, if x is a number, x squared is always bigger than or equal to 0. And if y is a number, then y squared is always bigger than or equal to 0. And if I add two numbers which are always bigger than or equal to 0, then my result is always going to be bigger than or equal to 0. Now, I'm also going to say that this cannot equal 0 since x and y aren't 0 either. So I can say that x squared plus y squared is always positive because I have square numbers, and square numbers are always positive. And if I add positive numbers, I get positive numbers. And we know that it's not equal to 0 because we said before that in our assumption that x and y aren't equal to 0. Okay, so what does that tell us? If x squared plus y squared is equal to negative xy, and x squared plus y squared is positive, that tells us then, therefore, negative xy is bigger than 0. So that tells us that if I divide both sides by -1, if I'm dividing by a negative number, it means I flip the inequality sign. So therefore, xy is bigger than 0. Now, do you see a contradiction? We used the same statement, the same relationship, that 1 over x plus 1 over y equals 1 over x plus y, to arrive at, yeah, xy is positive. But then if I looked at it from a different perspective, we also said that xy is negative. But one single number can't be both positive and negative. So that's our contradiction. So we use the same relationship to arrive at a contradiction, something that doesn't work. So therefore, what we originally assumed, which was this relationship, is false, which means our original statement must be true. So we would write that, but xy can't be both positive and negative, therefore we have a contradiction. So supposition, so whatever we assumed at the start is false. So therefore, my original statement must be true that 1 over x plus 1 over y does not equal 1 over x plus y for x and y values not equal to 0. So in summary, first start off by writing down what you want to show, which is this is my original statement I want to show is true. We are going to apply the technique proof by contradiction, which means suppose not. Suppose our original statement is not true, or the false part of it, the opposite of it, right? So suppose that this, or the opposite of not equals to is equals to. So suppose that this relationship holds for xy not equal to 0. Now work with this relationship which we're supposing and arrive at a contradiction. Using algebra relationships, we can establish that xy is positive. And then if we consider the same relationship that we assumed from a different perspective, we get that xy is negative and not equal to 0 because x and y aren't equal to 0. So we have a contradiction because that's saying that a number is both positive and negative and not 0. So that's not possible. So we have a contradiction. So whatever we assumed at the top here, which is not the opposite of my original statement, is false. So if it's false, that means my original statement must be true. So proof by contradiction is really following these kind of patterns and using some of your number logic and number patterns to arrive at a contradiction, which means our supposition is false.